This third video in our Getting Results with RUSLE2 playlist sets the stage for our upcoming demonstration of a RUSLE2 plan calculation. In this video, we'll illustrate the all-important process of compiling input data before starting up the software and running your calculation. As mentioned previously, this guidance document on getting results with RUSLE2 plans is an important complementary resource for this video playlist. As you can see, Step A in this document lists things to do to get ready before you start your calculation. Sub-step A1 is make sure you have all your necessary input data. Sub-step A4 encourages you to find, build, and/or organize the management files you will need in your calculation. We're going to illustrate how to do both right now. Here's an overview of the scenario we're going to model in our upcoming RUSLE2 demonstration. We've got a 33-acre grass hay field, as shown here, in Goochland County, Virginia. It's a good training location because it's pretty close to our state office in Richmond. And many past classes have visited this site to practice shooting slopes, which is what we call collecting topography inputs for RUSLE2, so we know a lot about the field. We're going to assess the suitability of converting this field from perennial grass to an annual commodity crop with tillage. As we go along, we'll be illustrating another one of our recommendations, that you record your inputs for your calculation in some kind of organized fashion. One option shown here is to use this Virginia RUSLE2 data collection sheet, which is available on the Virginia NRCS FOTG. So we already know our R, or climate factor, for this calculation, so that's shown here, and that is Goochland County, Virginia. Now we need to determine our K factor, or soil type input. So the soils map for this field shows 3 soil types. We've got down here 11B2, Fluvanna fine sandy loam. Up here in a large portion of the field we have 14B2, Georgeville fine sandy loam. And here on the field edges we have a 28C3 Pacolet clay loam. For this exercise we're going to pick a single soil type to represent the field, and that is an example of lumping, or picking one input to represent what is in fact a range of attributes in the real world. And the soil type we're going to use to represent the overall field in this case is going to be the Georgeville fine sandy loam. So now we're back to our data collection sheet, and we can note the soil map unit here in this box. Next we need RLS, or topography input, slope length and slope steepness. So this field has a range of slopes. We already know this from the soil map unit symbols because we've got some B slopes and some C slopes. We can also see on this contour map the contour lines that are closer together in this area indicate steeper slopes, while contour lines that are further apart indicates flatter slopes. So for this exercise we're actually going to model 3 different slopes within the field, and this is an example of splitting. By using a range of slopes, it'll help illustrate how topography impacts erosion and RUSLE2 outcomes. It's also going to illustrate the key feature of a RUSLE2 plan calculation, which is our ability to model multiple management alternatives on multiple fields or slopes with a single file and print out in RUSLE2. So we're going to use representative LS measurements from past visits. We're going to have a flatter slope around 4% steepness, an intermediate slope around 8%, and a steeper slope of 12%. And this table shows the length in feet as well as the steepness in percent that we're going to input for these 3 slopes. And you'll notice the description here of the 4% slope as a permissive choice. If we were to represent this entire field using a 4% slope for it, we would underestimate erosion risk for the steeper areas of the field, and that would potentially lead to more permissive or less protective recommendations for soil management. Meanwhile, if we represent the entire field as a 12% slope, it will likely result in more conservative or protective soil management recommendations. The thing to keep in mind is in many cases, the planner will choose a single topography input to represent a relatively diverse field like this. As a reminder, as mentioned previously, that planners will often need to make judgment calls when trying to represent a complex real-world scenarios and landscapes in the relatively simple RUSLE2 model. Now we can note our LS topography inputs, and here we said C notes, and down here we're clarifying that we're going to compare 3 slopes. So the next input we need is our C factor, or our crop management information. For this upcoming plan demonstration, we're going to model and compare two crop management scenarios, a baseline of perennial grass, which is represented by this image, and an alternative management consisting of continuous soybeans with multi-pass spring tillage every year and no winter crop, no winter cover crop. And in the early summer, that might look something like this. Now, a key question is, where do we get the RUSLE2 management files we'll use to model these scenarios? And that's a question we encourage you to always tackle up front before you start your RUSLE2 calculation. And our answer in this case is that the files we need are available as pre-made single-year management templates for CMZ 66. So available as pre-made single-year templates, what does that mean? We're going to try to answer that with a quick refresher on how RUSLE2 management files are organized. As always, keep in mind, if you encounter a topic like this in these introductory videos that you need to know more about, you can consult some of our complementary resources for more details. Okay, so now for the quick refresher. Remember that RUSLE2 management files are organized into crop management zones, or CMZs, and these are broad regions of the country with relatively similar climates, soils, and cropping systems. Goochland County, Virginia is in the Piedmont region, CMZ 66. Once loaded in your database, each CMZ folder contains 4 subfolders, and subfolder A contains single-year, single-crop templates. For this particular calculation we'll be doing, there are pre-made files that represent our desired management scenarios in this folder. Now let's open RUSLE2 and take a look at these management templates. I'm in my gray RUSLE2 screen here, and so the first thing I always do is take my eye down to the bottom right-hand corner of the screen, check that I'm reading the correct Moses file, which I am, Moses database. Next, I check my user template, make sure that my screen view is going to be what I expect, and it is. So now we're looking for some single-year, single-crop templates in CMZ 66. I'm going to go up here to my yellow clipboard icon, which is my management's portion of my database. Open that. I'm going to navigate here to CMZ 66, the A subfolder, single year, single crop templates. And our baseline rotation is perennial grass hay. And here under E01, I see permanent grass hay, so let's open that. I've got a cool season fescue choice, a warm season Bermuda grass choice. We'll go with the cool season. Open that. And take a quick look at this template. We have a rotation duration of 1 year. Average annual stir is 1, which is extremely low. It's a no disturbance type rotation. And if I take a quick look at this, this is how we represent perennial grass hay in RUSLE2. So this template looks good. We will draw it into our calculation coming up next. What about our alternative management, which is continuous soybeans? I'll go back here, navigate up, and here we see in B04, this folder has a soybean single year and single crop templates. We'll look in there and we'll choose wide row. And here we see soybean management templates for early planting, mid planting, and late. So we'll go with early. We'll choose 102, soybean wide row early, clean tilled, this 3 times. So what do we see? It's a 1 year rotation again, which is what we want. Average annual stir of 94, that's pretty high. And the reason is, if we look at our management line by line here, we have disking. March 30th, disking again, another disking here in late April, and then planting soybeans May 1st, harvesting October 7th. The vegetation is soybeans, and the yield is 40 bushels. So this looks good, and again, this is the other management we'll pull into our calculation when it's time to do that. Now, I'm not spending a lot of time analyzing these managements. I've already done that previously. But as some of our complementary resources on RUSLE2 management files will explain, finding, analyzing, building, and organizing managements can be a big job, and it is really the heart and the hardest part of using RUSLE2 correctly. In this case, the fact that we've chosen some simple rotations that are already available is going to make this job much easier. So now we're back in our RUSLE2 input data collection sheet. Here under the C factor, we've noted some key information. We're going to compare 2 managements, perennial grass hay versus continuous soybeans, 40 bushel yield, etc. And we've noted that the templates that we need to represent these rotations are in CMZ 66 subfolder A. So the next thing we want to look at is our support practices, what we traditionally call a P factor. And we're not going to have any credit for support practices. In particular, we're going to assume no contouring, so the default RUSLE2 setting with crop rows going up and down the slope. And as far as rotational strip cropping or filter strips or other support practices, we've got none. So that concludes this video. Next, we'll show a live demonstration of how to input the data we just compiled into a RUSLE2 plan calculation.